Alright, welcome back to the video of my channel, f_exe. Today we're going to look at another problem solving video in my playlist, so here it is. So find the area of the figure below, and you might be wondering, well, isn't this like a primary 3 or primary 4 question? Well, it is. However, there's a little twist to it because I'm just going to show you another method of solving this question. So let's just use this in the noob way, which is what elementary students will do in this case. So they will calculate the area of this rectangle, which has length 8 and width 2. That will be 8 times 2, of course, plus the area of this trapezium, which has length of parallel lines 3. And if you want to find this length, you know that this 2 is equal to this 2 and this 2. And since this whole length is 8, therefore this little length right here will be 8 minus 2, which is 6. So the area of a trapezium will be a half times the sum of the parallel lines, which will be 6 plus 3, multiplied by 4. And if you calculate this, you get 16 plus 18, which will give us 34 units squared. So that is it. However, if you want to do this the overkill way, which we're going to use integrals for this case, which will be pretty insane considering this is a pretty easy question. This is a elementary question, so yeah. So how are we going to solve this using integrals? Well, first, we can just set up a xy plane in this shape. So this will be the x-axis, for example, and this will be the y-axis. And the origin will be at here, which is 0, 0. And let's just determine the coordinates of these lines here. So this point here, well, notice the vertical distance between this point and this point will be 8. So the coordinates of this point will be 0, 8. And you can just do the same thing right here. Notice the horizontal distance here is 2. So the coordinates will be 2, 0. Likewise, you get up here are 2 units, so there will be 2, 2. You go up, you go to the right 4 units, there will be 6, 2. You go up here 3 units, that will be 6, 5. And lastly, for this, you go 2 units to the right, that will be 2, 8. Alright, so those are the coordinates marked down. Now we're probably going to do some marking of these equations of lines, but only plenty of them because we're going to use some of them. So the first one will be, let's see. So the first one will be this line right here, this horizontal line, and the equation here will be y equals 8, since this line is always on the coordinate y equals 8 in this case. So that's the first line. Now the second line will be this thing right here, which has, y equals 2. Equation of y equals 2, I should say. Now for the last equation of line that we need to consider is this line. Now what is the equation of this line? Well, that's pretty simple. We can just use the Poinsot formula to determine the gradient, and then substituting a pair of coordinates into our Poinsot formula to find the y-intercept of this, and then we're done. So the gradient in this case, m, is equal to the difference in the change in the y-axis all over the change in the x-axis, giving us negative 3 over 4. That's our gradient. And substituting this into our Poinsot formula, you get y equals negative 3 over 4x plus b, where b in this case is our y-intercept. Now we can just substitute, for example, this set of coordinates into our equation. So y will become 8, and x will be 2. And then solving for b, you'll get b is equal to 19 over 2. So this equation will reduce to y equals negative 3 over 4x plus 19 over 2. So this is the equation. Now let's set up our integrals. The first integral will be the area under the line y equals 8 from 0 to 2. So let's just set up our integral here. So our area will be the integral from 0 to 2. That's our limitation for our first part, which is the rectangle of the equation y equals 8. So we just put 8 inside here. And don't forget we're doing dx. Plus the second part, which will be the area bounded between two lines right here from 2 to 6. And I should have marked this coordinate right here as 6, 0. So we're evaluating this from 2 to 6. Now what to put inside this integral is the question. Well, recall if you have two graphs or two functions, and the one is bigger than the other, then the area bounded between them will be the integral of the greater function minus the smaller function. And in this case, our greater function will be this thing, and our small function will be y equals 2. So this will be negative 3 over 4x plus 19 over 2 minus 2 dx. In integrating x, I'm integrating 8 will be 8x. We're evaluating this from 0 to 2 plus the integral of this part will be, let's see, so we're just going to integrate this first. So that will be, I'm just going to open a parentheses, 3 over 8 x squared. Notice if you differentiate this, you'll get this term back, plus 19 over 2 will become 19 over 2x minus 2x. Well, perhaps you can just combine 19 over 2 with negative 2 before you integrate them. That's also a viable option. So we're integrating this from 2 to 6. Now I'll just let you guys to evaluate this, and from this part you'll obviously get 16, and this part you'll get 18, and in total you'll get 34 units squared, which is our exact same answer as if we did this in the first case. So that's a way to solve this question using integrals. So hopefully you guys enjoyed this. Please subscribe for more videos, and I'll see you guys in the next video. Goodbye.